Hi buddies, welcome to lecture 11. In this lecture, we want to learn some additional EIGRP configuration commands. Therefore, after this lecture, I expect you to be able to configure some EIGRP parameters. Let's start our today's mission. Bandwidth and delay are general parameters of interfaces, and you could configure these parameters with any reasons other than EIGRP configuration. But for now, we want to manipulate these parameters just to change EIGRP result. As you could remember, by default, if everything is default from K1 to K5, EIGRP formula become to this formula, and bandwidth and delay are involved in this metric calculation. Now we want to manipulate this formula and see the consequences. For this reason, I configure a network just like this: 2 routers, 1 host, 2 networks, one in IPv4 and one in IPv6, and I configure EIGRP for both IPv4 and IPv6. We could check this configuration. Show IP EIGRP interfaces. As you could see, I configure fast Ethernet 0/0 and 1/0 for IPv4 and show IPv6 EIGRP interfaces. And you could see for IPv6 also these interfaces are EIGRP enabled, and show IP route for seeing the routing table. For router 1, networks 1.0 and 2.0 are both directly connected. But for router 2, if I check show IP route, you see that the route of network 192.168.1.0 is learned from EIGRP. And show IPv6 route, you see that the network 2001.001/64 is learned from EIGRP. As you could see, the metric of this route is this for both EIGRP version 4 and EIGRP version 6, because the formula is the same for both. Now we want to change bandwidth and delay and see the consequences on this metric. We configure bandwidth and delay on fast Ethernet 0/0 of router 1 to see the impact on router 2. Now let's start our configuration. I clear the screen and configure terminal interface fast Ethernet 0/0 and configure delay with delay. Here we configure delay in tens of microseconds in terms that EIGRP use this, but when we enter show interfaces command, you see that this parameter is shown in terms of microseconds. I will show you. Let me show you before I configure this parameter. You could see the bandwidth and delay which is configured on the interface with show interfaces and the related interfaces, or otherwise these parameters are shown for every interfaces that are existing on your router. I want to see these parameters only for fast Ethernet 0/0. As you could see, the bandwidth is 100,000 kilobits per second. It is a fast Ethernet, and the delay is 100 microseconds. Now I want to change these parameters. So I go to interface fast Ethernet 0/0 and say delay is 20 and bandwidth is in kilobit per second, and I change it to, for example, 2000. You could see the impact on the interfaces with show interfaces fast Ethernet 0/0, and as you could see that the delay is 200 microseconds and the bandwidth is 2000 kilobits per second. Now router 2 must change the metric because the parameters are changed. Therefore, here after clearing the screen, I say show IP route again, and you see that the metric is changed for both EIGRP version 4 and EIGRP version show IPv6 route, and you see that for this metric is changed too. Therefore, if you change bandwidth and delay, which is configured on the interfaces, EIGRP calculation is done again and new metrics are calculated and concerned in routing table. I'm sure you remember that EIGRP is sending hello messages every 5 seconds in some networks and every 60 seconds on some other networks. These timers are called hello interval, and by default, if one router does not send EIGRP hello messages 3 times of hello interval, for these networks becomes 15 seconds, and for these networks become 180 seconds. The other side thinks that this router is not reachable anymore and deleted from neighbor table. These timers are called hold time. In this part, I want to show you that how you could change these parameters manually. Remember that I told you this before too. If you change hello interval, this equation is not preserved. I mean that if, for example, you change hello interval from 5 to 10, the whole time is not changing to 30 automatically. And if you want to preserve this equation, you have to change whole time manually. Now let's configure these parameters. But before that, let me tell you 2 tips. First, these parameters, hello interval and hold time, are configured per interface, and you could have different hello interval and hold time on different interfaces. So first tip, this configuration is done per interface. Secondly, you should know that it's very important. iOS does not prevent you to set hold time smaller than the hello interval. However, this could make big problem for your EIGRP routing. If you configure hold time smaller than hello interval, neighborship relation goes to flapping between up and down between 2 routers. And this is happening for your routes in your routing table too. So please pay attention to the values which you configured on hello interval and hold time. Do not configure hold time smaller than hello interval. Now let's do it. So we go to fast Ethernet 1/0, which is between 2 routers. I select this interface, and we say that for IPv4, we say that IP hello interval, and you select EIGRP. And after that, you should select the AS number, and finally the seconds between hello transmissions. I select, for example, 10. For hold time, again for EIGRP for IPv4, the command is IP hold time EIGRP 1 and 30. I set these 2 parameters for IPv4. Or for EIGRP for IPv4. For IPv6, the command is the same, only IP substitute with IPv6. IPv6 hello interval and EIGRP, the AS number, and the time that you want to set. And IPv6 hold time EIGRP 1 and 30. How could we verify this configuration? Let me clear the screen again. First of all, you could check it with show running config. When you change it, you could see your changes in running config on fast Ethernet 1/0. You see that the IPv6 hello interval are changed, and for IP changes are here. And if your iOS version, like mine, is not very new, when you issue show IP EIGRP interfaces detail, only the hello interval is shown to you, but I changed on fast Ethernet 1/0. But if your iOS is newer, the whole time is shown in front of the hello interval, and you could see it here. For my iOS, only I could see hello interval. So if you have EIGRP for IPv4 and EIGRP for IPv6 both on your router, and if you want to change hello intervals, you have to do it separately for these 2 protocols. And today's final command, passive interface. You may have a network just like mine, a router at your network boundary which is connected to hosts. You may say that, why should I send EIGRP hello messages on this interface? Should I enable this interface on EIGRP? If you want to ask router to advertise this network, you have to enable EIGRP on this router. But after that, you could disable sending hello messages on this interface by using the passive interface command. I capture router 1 fast Ethernet 0/0 packets here with Wireshark, and as you could see that hello packets are sent on this interface from IPv4 and from IPv6. Now we want to stop sending hello messages on interface fast Ethernet 0/0 without changing the advertising of the related route. First, for IPv4 router EIGRP 1, and here we say that passive interface fast Ethernet 0/0. And now you could see that no any other IPv4 hello messages are sent on this interface, and only IPv6 packets are sent. If we want to disable sending hello messages on this interface for IPv6 too, we have to repeat this configuration on the router subcommand of EIGRP for IPv6. Therefore, I go to IPv6 router EIGRP1 and say that passive interface fast Ethernet 0/0. And now sending hello messages on this interface is stopped too, and you could see that there is no any other hello messages which is sending on this interface. Now router 2 still knows about the related network which is available through router 1, and nothing is happened to routing, only we stop sending EIGRP hello messages on that interface. Show IP route still is here, and I could ping 192.168.1.1, which is the IP address of my PC. You could see it is reachable. And for IPv6, I repeat this process, ping 2001.0.0.1.1. Again, this is my host IP address, and you could see that IP connectivity is okay between these two devices. We could configure passive interface in a reverse position. I mean, we could disable sending hello packets on all interfaces, even with EIGRP configuration, and after that accept some interfaces. For this reason, we could configure our router like this. For EIGRP for IPv4, we say that router EIGRP 1, for example, and say that passive interface default. If we enter this configuration, sending hello messages on all interfaces would be disabled. And after that, if we want to enable some interfaces, we have to say that no passive interface, for example, fast Ethernet 0/0, and do this process in a reverse position. It's your choice. You could keep enable all interfaces and say passive interface to some interfaces that you do not want to send hello messages on them, and you could do it in a reverse position. You disable all interfaces for sending hello messages and accept some interfaces for sending them. This process could be done for IPv6 too, and we could configure like this: IPv6 router EIGRP1 and say passive interface default and accept some of interfaces by no passive interface fast Ethernet 0/0, for example. Now it's summary time. In this lecture, we learn how to configure bandwidth and delay on interfaces and see the impacts on EIGRP metric calculation. We learned that how to change hello interval and hold time both for EIGRP for IPv4 and EIGRP for IPv6. And finally, we see that how could we disable sending EIGRP hello messages on desired interfaces with passive interface command. I hope this lecture helps you to improve your knowledge, and see you in the next lecture.